Okay, everybody, let's take a look at question 4.49, and this is more of a rote memorization problem. Maybe not so bad, but if you know the rules for determining the oxidation numbers or oxidation states of elements, then this shouldn't be so bad. So for part A, we have SO2. So for sulfur and oxygen is the one that we know. Oxygen is going to be 2- for the most part. It's not always, but 99% of the time, oxygen is going to be 2-. And so this is a compound, so the total charge on the compound adds up to 0. So that means this is 4-. So that means we want sulfur. Sulfur is going to be a 4+. Okay. So now for B, we have this. We have this compound. I don't know why I'm drawing the Lewis structure of it. Okay, but it's COCl2. Now, let's keep in mind here that that this is a capital O, okay, which is different than COCl2. So all that, like, you know, oh, do we have to worry about capitalization stuff? Yeah, it makes a difference because this stuff, this phosgene, it's not very healthy for you. Okay, so let's take a look. Let's do this. So chlorine is typically a -1, okay, and oxygen is typically a 2-. So let's see here. We have 2 of those, so that's 2-. Okay, and then oxygen is a 2-, so that's 4-. So that means that carbon must be a 4+. Okay, so now for part C. C is manganese and potassium permanganate. Okay, so again, let's take what we know. Oxygen is almost always 2-. So there's 8 of those, that's 8-. And potassium, remember the oxidation state of the metals is whatever the charge is on the metal ion. So in this case, it's a 1+. So this is 1+, so that means that manganese here must be a 7+. Okay, so let's take a look at D. D is HBRO. Bro, we got this. Okay, so let's see. Oxygen, again, oxygen 2-, hydrogen 1+, and now let's see, there's one of these, one of those. So that means that bromine must be a 1+. Okay, so E. And keep in mind, when I do something like this, I'm starting with the ones that I know is mostly, okay, I'm starting with like the rules on the top of that refer back to my video, but I'm starting with the most common rules. This is almost always 2-, and then I go to hydrogen. Hydrogen is more often than not 1+, so this one is more likely to be 2-, and this is 1+, but this is definitely 1+ here. Okay, so that's how I do this. So when I have like PF3, I start with the F because I know F always, no matter what, has an oxidation state of 1-. Okay, and so that means that's 3. Okay, so that's 3-. So that makes phosphorus 3+. That's the one that can change. Okay, and now let's look at F. So this is K2O2. Now this is funny because this is a special example of how oxygen's oxidation state or oxidation number doesn't always have to be 2-. So we're going to look at this. If we're trying to figure out this one, then the only other thing to start with is potassium. Potassium always has a charge or an oxidation number of 1+. So if there's 2 of them, that makes this 2+. A total of 2+. So that means oxygen has to total up to 2-. So that makes each oxygen atom a 1- charge. And that is what makes peroxides. That's one of the reasons why peroxides are reactive and not very good to do things with, is because of its charge or the oxidation state of oxygen. Okay, so that is a review of, or that shows you how to do question 4.49 in Brown, LeMay, Burson. Have a great night.